All right, so parabolas are one of the conic sections, and you get it by slicing a cone at an angle like this. So let's talk about the different characteristics of parabolas. How do you get a parabola? Well, it's kind of exciting actually, because a parabola is the locus. What's a locus? It's just a set of points. It's a set of points that map out a geometric shape. So if you get all the points that map out a circle, that's a locus. If you get all of the points that map out a parabola, that is a locus, those points together. All right, so a parabola is a locus of all points in a plane that are equidistant from a fixed point and a specific line. And what is that fixed point and the line? The focus and the directrix. Okay? So suppose there is this line that we're going to call directrix, and then there is a point that we're going to call a focus. If you can come up with a point that is equally far away from that line and that point, okay, then you map that as one of your points on your parabola. So here's the line and here's the point. Now, I want a point that's, let's say, 5 centimeters from this line and 5 centimeters from that point. Oh, that one right there. Now I want another point that's 7 centimeters from the line and 7 centimeters from the focus. 7 centimeters away and 7 centimeters away, that one. Now I want a point that's 3 centimeters away from both. 3 centimeters away, 3 centimeters away, that's that point right there. And if you map all of those points, you draw a parabola. That's what a parabola is. Okay? That's kind of amazing, is it not? Yeah, okay. So if you are sitting on a parabola, like if you have a roller coaster that is the shape of a parabola, at any given point, you're equally far away from that line and the focus. Okay, so they're both equally far away from you. That's kind of pretty cool. All right. Now, some features then of a parabola. We've got what we call the axis of symmetry, and you know about this because you've been graphing parabolas. What equation gives you a parabola?
B over 2a? No, negative b over 2a.
What do we call those? A what type of equation? A quadratic equation. Brownie points for you. So, we've been graphing this, and you know that there is an axis of symmetry, and it goes right down the middle, right there. Okay? And the parabola is symmetric if you fold it around that line, that axis of symmetry. Okay? The axis of symmetry is perpendicular to the directrix. The vertex is the intersection. So here's the vertex. It's the intersection of the parabola and its axis. We know where the vertex is. So you've got the vertex, and on this axis of symmetry, okay, you've got the focus and the directrix is on the opposite side. That's what we're going to do this period. Okay. Now, you've been graphing quadratic equations forever, okay? And normally they look like this, y equals x squared. And your parabolas normally look like this, right? They're vertically positioned. So when the variable is squared, now notice in a case of a quadratic equation, one of the variables is squared and the other one is not, okay? So that spells out a parabola. Now, when it's the x variable that's squared, you get a vertical parabola that looks like this. All right, so you've got the vertex here. Okay, that's the vertex. The focus and the directrix are equally far away from the vertex. So if you're sitting on the vertex, if you go 2 units up to hit the focus, then you have to go 2 units down to hit the directrix. Okay? So focus and directrix are equally far away from the vertex. Another way to say that is the vertex is exactly in the middle of the focus and the directrix. Vertex in center of focus and the directrix. All right? Now, how far is the focus from the vertex? Well, we call that P. Okay? P is the distance between the focus and the directrix, the vertex. So look, let me make this bigger because they just made it too tiny. This distance here between the vertex and the focus, that is P. We call that P. Okay?
Wait, so like there is a distance between the
Yeah.
Directrix and the vertex there? Because it looks like
I know, they didn't do a good job of drawing it, but there is, okay? And it could be either very close or very far. Now, if P is greater than 0, the focus is higher up than the vertex. If P is negative, the focus is lower. Okay?
the focus is on the parabola.
No, the focus is inside the parabola. So the way it looks, if you draw a better diagram, is this. If this is your parabola, and that's the axis of symmetry, the focus is somewhere here, okay? And this distance is P, okay? Now, if you go P units down, what do you hit? The directrix, okay? All right. Now, look at this for a minute. If you have a parabola that opens vertically, okay, here is your vertex. Now, where's the focus? It's up on the axis, right? So if I'm at the vertex, suppose my vertex is at 3 and -2. Okay? And I have to go to the focus. Is my x-coordinate going to change? If I'm here and I'm going to go up to the focus, my x-coordinate isn't going to change, right? It's my y-coordinate that's going to change. So how much do I go up? I go up p units, okay? So where is the new coordinate now? Well, let's see. My vertex always has the letters h and k. Now, if I'm at the vertex and I have to go to the focus, I have to go up on this line, on this axis of symmetry, right? My h stays the same, and I add p to the y-coordinate, okay? So let's take this example. Look here. All right. Suppose this is my vertex at 3 and -2, and this is the axis of symmetry, okay? Now, if P is equal to 4, okay, where would my focus be? It's somewhere on this line.
2.
So I have to go up 4 units, right?
3, 2.
I have to go up 4 units. 1, 2, 3, 4. It's going to be at 3, 2. So what did I do? I took this number and I added 4 to it. Okay? So if you take the second number and add 4 to it, you go to your focus. All right, now how am I going to go to the directrix? Yeah. How do I go to the directrix?
Subtract 4.
Subtract 4. So from -2, I go down 4 and I hit what?
3 negatives.
Y equals -6. That's my directrix. All right, so how did I get to the directrix? It's y equals k minus p. And the axis of symmetry is x equals that first number h. Okay? Now, all this gets translated in the other case. Suppose now it's not the x that's squared, but the y that is squared. All right? If the y variable is the one that's squared, my vertex again is h and k. Now, my axis of symmetry is horizontal. That means if I'm at the vertex and I have to go to the focus, do I have to go horizontally or vertically? If I'm at the vertex and I have to go to the focus, I have to go horizontally. So my h is going to change and the k will stay the same. Okay? The axis of symmetry is y equals k and the directrix is x equals h minus p. All right, let's do an example. So I tell my students this all the time. So suppose there is a town called Parabola Town. And on this Parabola Town, there is this major street. It's like Main Street, but it's called the Axis, right? This is the major street. Everything exciting happens on that major street. So you're on that major street. What do you have on there? What are some of the stores on there? Well, you've got the Focus, you've got the Vertex, and then if you go, you hit another street, the Directrix, all right? But everything has to happen on that axis of symmetry. All right, so let's take a look at this one. You have an equation here. We have to figure out what the vertex is and the focus and the axis of symmetry and so on. So what is the vertex of that one? Where is it? Well, it's where? -1 and +3. You have to switch the variables. You have to switch the signs because it's y minus k, x minus h. All right, so this is going to be -1 and 3. Now, because the equation is y minus k, so to put it in there, you have to subtract. And then to take it out, you have to subtract again. Just like anytime when you're extracting these numbers from here, yeah. Right. So this is -1, 3. Now, if the y is squared, is this a horizontal parabola or a vertical one? If the y is squared, this is a horizontal one. The vertex is -1 and 3 right there. That's the vertex. Okay? And if it's horizontal, I'm just going to sketch it for now. It looks like that, right? Sorry, it looks like this. Okay? I'll tell you how to figure that out in a minute. So that means this is the axis of symmetry, right? Now the focus is going to be on the axis of symmetry. So just have that picture in your mind so you know how to orient yourself. Now, from this number here, that number is 4p. So 4p is equal to -8. That means p is equal to how much? -2. Okay? That's the formula, right? So here, it's x minus h squared or y minus k squared is equal to 4p x minus h. Okay, so the equation is y minus k squared is equal to 4p x minus h. Okay? All right, so that's p. Now, if everything is on this street right here, that means, am I going to go horizontally or vertically to hit the focus? From the vertex, do I go horizontally or vertically? Horizontally, right? If I'm going to go horizontally, now my focus is going to be somewhere over here. My y isn't going to change, right? But the x is going to change. So the way I do that is this. The focus, if this is h and k, it's going to be h plus p and k. All right, because the y coordinate isn't going to change. So f is going to be -1 minus 2, comma 3. That means the focus is at -3, comma 3. So -3, comma 3, right there, that's the focus. Does that make sense that the focus is there? It does. Okay? Now, the axis of symmetry and the directrix. So for the axis of symmetry, it passes through the y-axis here, right? So it's going to be y equals that number k, 3. That's it. Y equals 3. Now, for the directrix, if we did y equals something here, the directrix has to be x equals something. And if I did h plus p here, then I got to do h minus p there. So x is equal to -1 minus -2. X is equal to 1. Okay? So x is equal to 1 right there. That's the directrix. And now I have no other choice for my parabola, so it looks like this. Once you have your focus and your vertex, just sort of eyeball it like this. Okay? That's all I want. No. Okay? Yeah. That's all I want you to do. And now if you want to check, okay, you go 2 units this way to the directrix, 2 units this way for the focus. All right? Because this is negative, the parabola opens in the negative direction to the left. So that's how we knew that. Because this number is negative. This one. The directrix is this line. All right, let's do one more. Now, to write in standard form, we have to do what we call completing the square. All right, so here's what we do. It's x squared minus 8x plus a number, remember, equals, now you move this to the other side, so it's y minus 18 plus a number. Because whatever I add here, I must add there as well. What number goes in that blank? It's 8 over 2 squared, so it's 16, and I have to add the same number there. Okay? Now, when I complete the square here, I have x minus 4 squared is equal to y minus 2. And I'm done. Okay? I am done. Now, I have an x squared here. So is my parabola going to open vertically or horizontally? Vertically. What is the number in front of the parentheses here? 1. So from there, I get that 4p is equal to 1. So what's p? It's 1 over 4. Okay? Now, let's figure out what the vertex is. The vertex is 4 and 2. So if I go here at 4 and 2 is my vertex, that means, okay, if I go up 1 over 4 units, I hit the focus. And if I go down 1 over 4 units, I hit the what? The directrix, right? So the focus is going to be here, and the directrix is going to be there. So now, how do I find the focus? Am I going to add 1 over 4 to the 4 or to the 2? To the 2, right? Because the 4 is going to stay the same. I'm just going up vertically. So it's going to be 4 comma 2 plus a quarter. Okay? That means the directrix is equal to y equals 2 minus a quarter. Do you see the correlation here? In this case, we do 2 plus a quarter. Here we do 2 minus a quarter. That's always going to be that way. And if we're adding this to the y coordinate, then this is y equals. Okay? So you can remember like that. Okay, so then the focus is 4 comma 9 over 4. And the directrix is y equals 7 over 4. Now, where is the axis of symmetry? 2 isn't enough. X equals 4. X equals 4. Now, if this is y equals something, then the axis has to be x equals something. They're perpendicular to each other. And if it's x equals something, well, x has to equal the vertex. Okay? So that's the axis of symmetry right there. The directrix is right there, and the parabola will look like this. Huh? This is the directrix. It's 7 over 4. So it's 1.75.
So how do you use this one statue graph?
You're just going to plot them and eyeball the parabola.
Always?
Yeah. Okay? Any questions? All right. Now, the closer the focus is to the vertex, the wider the parabola will be. Okay? Yeah? Okay. All right. Now, how do you come up with equations for parabolas? Now we're going to be going backwards, and this'll like help you, I think, focus more. You get it? Come on, yeah. Okay. So we got to write an equation for this graph. So what are we given? We're given the focus and the vertex. What do I do first is I sketch sort of like a rough sketch of this. The focus is at 2 and 1, and the vertex is at -5 and 1. Okay? That means this parabola is going to open this way. That means, is it an x square or a y square?
Y squared.
It's a y square. So what does that equation look like? It's y minus k squared is equal to 4p x minus h, right? So now what do I need for this? I need p and I need h and k. Well, where is h and k?
H and K are in the vertex.
H and K are the vertex. All right, good. I got those. Now I need P. Okay? Well, look, if I go from the vertex horizontally to the focus, right? I'm changing the X value, so that means this is H plus P. Okay, that's H plus P. So now, if H plus P is 2, that means -5 plus P is 2. So what's P? 7. Okay? Now, do I have everything I need? I do have everything I need. So y minus 1 squared is equal to 4 times 7, x plus 5, which means y minus 1 squared is equal to 28, x plus 5. Okay? Now, is there another way to find P? Right. This distance is also P. Okay, how much is that distance? 7. Okay? So, any which way, you get the same focus. You get the same P. All right. And we're going to sketch this. Whoops. We're going to make a narrow one. Okay. This is the axis of symmetry. Make sure it's symmetric, hence the axis of symmetry. Where is the directrix here?
7 the other way.
It's 7 the other way, which will be y equals -12, and I hate that it spills out of the graph. I should have been more cautious of that, okay? All right, so let's do 2 more. I have the focus at 3, -2. 1, 2, 3, -2. That's the focus. And the directrix is at y equals -1. Right there. Ooh, interesting. So where's the vertex? It should be where? If that's the directrix and that's the focus, the vertex is where? The vertex is exactly in between. It's exactly in the middle, right? So the vertex is going to be here. All right. How do I figure out where that vertex is? Well, you can subtract. So the y coordinate, the x coordinate of the vertex is going to be 3. And where is the y coordinate going to be? Well, if this is -1, I go down a half. So it's -1.5, right? Or -3/2. Huh? I like fractions. All right, now how much is P? How much is P? We don't have cell phones out. How much is P? P is 1/2, right? P is this distance right here. Okay, so P is 1/2. And is that all I need? That's all I need, right? So let's put it in the equation though. What kind of equation do we have for this? Is this going to open horizontally or vertically? It's going to open vertically but down. Excellent. It's going to open vertically but down. So what does that mean? P is negative. Yeah. So, the parabola always looks like this. The focus has got to be inside the parabola. The directrix is always outside the parabola. And if you have those in mind, there is no other way to draw this. Right? So the parabola opens down, which means P must be negative. Okay? And if you can remember all this, you don't have to do, you can also do this like, using analytic, like H plus P equals this and that. But if you can remember all of this and piece them together, you're totally fine. So what does the equation look like then for something that opens vertically? Is it the x that's being squared or the y? It's the x that's being squared, so it's x minus h squared equals 4p y minus k. Are you supposed to remember that all each time? Yeah, you are. So how do you remember? Well, you say it 10 times before you go to bed every night. Okay? So that's how you remember. All right? You should. X, so this is x minus 3 squared is equal to 4 times negative a half y plus 3 over 2. So x minus 3 squared is equal to negative 2 y plus 3 over 2. And if the focus is that close to the vertex, we're going to make a wider parabola. Okay? Who's used a flashlight in their life? Ever? Ben, you've never used a flashlight? Yeah. You've used the flashlight. All right? If you look inside the flashlight, like you have the bulb, right? You've got the bulb. Where is the bulb? And then behind the bulb is this silver curved surface, right? Underneath the bulb. That curved surface is a parabola. It's insane. Right? It's insane. When you go to like Costco or Lowe's or whatever, like they sell those parabolic, they sell those like circular heaters, right? That it's like this, and then you've got something here that heats up. It's a parabola. It's a parabola, right? And guess what? Both in the case of the flashlight and in the case of this, the bulb or the element here that heats up, you know where they place that? At the focus of that parabola. It really is. It is crazy. So then why though? Why? Because the heat, for example, it bounces off here. Because it's at the focus, if it bounces off there, then it reflects perpendicular that way. So here, reflects like that. Here, it reflects like that. Here, it reflects like that. And you've got this like even reflection of heat. It has to be a parabola. It's got to be a parabola. A circle wouldn't do the same thing. For a circle, it would reflect and then go back to the center. So it's got to be a parabolic shape. You see that? There you go. You use it every single day of your life. Every single day of your life. Okay, so here we have the focus at negative 1, 7. It opens up and it contains the point 3, 7. So 1, 2, 3, and 7. Right there. Now, if this is the focus, if it opens up, that means P is positive. And if it opens up, that means the equation we're using is x minus h squared equal to 4p y minus k. Okay? Right, or I would say opens left, right, and so on. And if this is h and k. Okay, I'm sorry. If it contains that point, it's not h and k. It's x and y. So we plug everything in, right? Now, what is this? Right, if that's the focus, okay, and if this opens up, so basically if it opens up, then it looks like this, right? It's something like this, okay? That means the vertex is somewhere here, right? If this is h and k, then this has got to be h and k plus p. Okay, because you go up p units. So this is h and this is k plus p. Now, if you have this setup, then there is a little bit of preliminary work to be done here. If k plus p is 7, then we have to solve this for k, and k is 7 minus p. Why do we do that? I'll tell you right now. Oh. All right. So now we have k, we have x and y, and we have h. We're going to plug all of this into the equation. So what is x in this case? 3 minus h, so minus negative 1, is equal to 4p. Y is 7 minus, how much is k? 7 minus p.
Wait, but isn't 3 minus negative 1 squared?
Yeah. So now, this is 4 squared is 16, is equal to 4p times 7 minus 7 plus p, which means 16 is equal to 4p times p. So 16 is 4p squared. P then, 4 is p squared. P then has to be plus or minus 2. But what did we determine from here? If it opens up, that p is positive, so p is positive 2. Now I have everything I need, right? If p is positive 2, do I have my h and k? Well, sort of, because k, remember, is 7 minus p. So k is equal to 7 minus 2, which is equal to 5. Does that make sense? Say yes. Okay, good. So now, x minus h, what is h? Negative 1 squared is equal to 4 times p, y minus k, and k we just said was equal to 5. So x plus 1 squared is equal to 8, y minus 5. Okay? So that means, if we graph this, if that's the focus, and we said it passed through 3 and 7, and where else? The vertex is now at 1 and 5, negative 1 and 5, so here. Right, no. So if you have a point 4 units remember this is the axis of symmetry? Okay? And if you have a point 1, 2, 3, 4 units that way, then you must have a point 4 units that way. So that's how that looks. Now, where is the directrix? No. Y equals what? 3. So y equals 3, not x equals 3. Okay, so the directrix is at y equals 3, and the axis of symmetry is at x equals minus 1. When I ask you for the axis of symmetry and the directrix, you have to give me the two in equation form, because those are equations of lines, all right? So this homework will be due the next time I see you, which is on Monday. Oh, that's right. Okay, so this is due when then? What's the date?
The 21st.
21st. Please do it before you leave.